also B map to B, but in order to show that we map to B itself, we put here P, permutation of P. Then another relation C, we have map to C also, so we put here P, like this one. So this is the simple idea of permutation function. So permutation function, it means we map to all the element map to itself. How we visualize the idea? The idea like this one. We have A, we have we have A, B, C. So we map A map to A, B map to B, C map to C. That's the idea or the concept of permutation function. So far okay? Class okay? What is permutation function? Class okay tak this idea? Okay, good. Okay, now we move to the formal definition of permutation function. Okay, permutation function, in formal definition, we discuss about bijection from set A to itself. A bijection from set A to itself, we call permutation of A. Sorry, permutation of A. Bijection means relation one-to-one function as a function. So it map to A itself, just like this idea. A map to A itself. A map to A. B map to B. C map to C. It can okay. It can be also like this one. We have A, we have B, we have C. A map to A, B map to B, C map to C. It can be also that A map to B, B map to C, C map to A. Another idea of permutation function like this one. But this is the basic idea. Later we will talk about this idea. A map to B, B map to C, C map to A. It can be also like A, we have A, B, C. It can be A map to B, B map to A, and C map to C. This another idea of permutation function. For this time being, the basic idea look like this one. But later, once we go further in another slide, we will talk about this idea and this idea. Okay, that's permutation function. Okay, first, for example, sorry. Okay. For example, once we have A equal to R, where let's F A map to A, it means we have a function of A map to itself, where we define as A, for example, 2A plus 1. Since F is 1 to 1 and onto, so F is a permutation of function. So we can write that A1, A2, A until En is a finite set where P is a bijection. P means we try to map to A itself in a bijection condition where we say that we list all the A and the corresponding of function value P A1, P A2, P until P AN, like this one. So the idea from P as PA, we have PA like this one. Previously we put like this one. A, PA. B, we have B, PB. We have C, PC. So this idea this idea, once in order to make sure this is permutation function, we convert to this metric relation. From set definition, set statement from statement in set, so we convert to metric. So once we convert to metric, so all this A, B, C, we put as A1, A2, A3 until AN. So that's why here we have A1 mapped to PA1, A2 mapped to PA2, and so on until AN mapped to PAN. This is the form of permutation function, the exactly form. So in next slide, we will utilize this form, not this form. Once we put like this form, it means permutation function. Okay, so we will deal with this form. Okay, now look on the same form. So we put as A mapped to A itself. So for every P to A, so we can say that if P is a permutation of finite state, so we can put as this set statement, then equal by this mapping. So we have A1, A2 until AN. So we can rearrange the mapping is PA1, PA2 until PAN for element in A. So this is a domain. This is a range representation. So this is domain A. This is a range for, this is a range for A. So we can see this is the first set for the relation. This is the second set for the relation where we split as domain and range. Okay, example 2. So example 2 given to you, if A have a value 1, 2, 3, so all the permutation in A, we can list out all the permutation can be happen in A. First, given to you relation 1, 2, 3. So this 1, 2, 3 in ideal standard map to 1 to 1, 2 to 2, 3 to 2. So the first permutation we can permute from here. Here. 2 map to 3. So once we focus this 3, we refer to this 3. 3 map to 2. Then 2 actually, this 2 actually is map to, this 2 actually is 2. We can say, we can draw like this one. 2, these 2 map to 3, 3 map to 2, like this one. So once we put in metric representation like this one, P1, 1, 1, 2, 3, 3, 3. It can be also the second permutation like 1, 2, 2, 1, 3, 3. It will be like this one. 1, 2, 2, 1, 3, map 3 itself. Here, 1, map to 1 itself. For this case also, map 1 to 2, 2 map to 3, 3 map to 1. So this one will be like 1 map to 2, 2 map to 3, 3 map to 1. So for the fourth permutation, it will be 1 map to 3, 3 map to 2, 2 map to 1. Another permutation that can be happen for this set will be 1 map to 3, 3 map to 1, and 2 map to itself. This is the possibility permutation can be happen when we refer to this set 1, 2, 3, or the element 1, 2, 3. That's the idea of permutation in set itself. Okay, that's it. Now we look on further. Refer to the second example. If we refer to P4, we try to compute P4 inverse P4. So what happened? Okay, once we refer to P4, this is P4. P4 have 1, 3, 2, 2, 1, 3, 2. So when we do the inverse for P4, it will be P4 inverse. Once we inverse, it will be 1, 3 will be 3, 1. 1, 2 will be 1, 2, 1 will be 1, 2. 3, 2 will be 2, 3. Because of we inverse. When we inverse, we change the position like this one. So once we have this value, we rearrange the position here 3, 1, 2. We rearrange back to the actual. It will be 1, 2, 3. So 1, 2, 3, 1 map to 2, 2 map to 3, 3 map to 1. Actually, once we inverse P4, it will be P5. Here, P5. Oh, sorry, it will be, P3, not P5, sorry, P3. So we inverse P4, actually, we inverse one back step, it will be P3, like this one. Okay, that's the idea of inverse. When we inverse P4 here, so from here we have, based on P4, 1, 2, 2, 3, 3, 1, so we change the position, it will be look like P3. Okay, that's example 3. Now we move to the second question in example 3. P3 is joined with P2. So once we get this symbol, it means P3 joined with P2. So we clear cut what is the value of P3 and what is the value of P2 based on here. This is P3, this is P2. So we list out based on the position. We write P3 first, followed by P2. So P3 is 1, 2, 2, 3, 3, 1. P2, 1, 2, 2, 1, 3, 3. So based on this position, we write here 1, 2, 2, 3, 3, 1 here for P2, 1, 2, 2, 1, 3, 3. Then we solve the problem. How to solve the problem? We start with the second set here. We refer to the second one. The second one, 1 map to 2. Once 1 map to 2, we need to find where is 2 in P3. So 1 to here. So 1 map to 2. These 2 map to 2. 2 map to 3. So the answer will be 1 map to 3. So it will be 1, 3. Second, 2 map to 1. Then 2 map to 1. We try to find 1 here. So actually is here. So 1 map to 2. So the answer will be 2, 2. So we put 2, 2. Then we have 3 map to 3. So these 3 map to 3. Then 3 map to 1. The answer will be 3, 1. So that's why here 3, 1. So once we get this answer actually equal to P5. Here, P5. Okay. So far, okay. Until example 3, how we do this operation. First, we take out what is P3. Second, we take out what is P2. Then we do this operation. Okay, when can you repeat again? Inverse P4 equal to P3. Example 3 part A. Okay. Sorry. Okay, this one. This one, wait. You refer to this question, Okay, good. Okay, I explain again, Now we move to back to the question. Okay, refer to this question. Firstly, you identify which permutation this question refer to. It means refer to P4. So we must refer to P4. So once we refer to P4, actually P4 here. 1, 3, 2, 1, 3, 2. Okay, so now we get 1, 3, 3, wait, sorry. 1, 3, 2, 1, 3, 2. 1, 3, 3, 1, 2. Okay. 3, 1, 2. Okay, this is before. Now when we do the inverse, this means inverse. Once we inverse, we change the position. It means domain will be as a range will be as a domain. So once we refer to P4, we do the inverse process, we change the position. So the answer will be, once we change the position, it will be P4 inverse, it will be 3, 1, 1, 2, 2, 3. Okay, until this step, okay, we win. Until this step, okay, good. Now we rearrange based on the ascending order. This, it will be this position we take to the first, second, and third. Once we take this position as a first, we must take the relation also. So it will be 1, 2. The second is 2. 2 is 3. Now 3, 1. 3, 1. So this is the answer. Once we refer to the final answer actually equal to P3. What is P3 here? Once we refer, actually is here. 1, 2, 3, 2, 3, 1. So here 2, 3, 1. That's why here put as equal to P3. Okay, wait. So the final, yes, the final answer must show like this one. We must rearrange back based on the position. Because the set based on 1, 2, 3, the ascending order. Yes, wait. You get the idea, wait. Okay, good. Okay, now we refer this one. This one, how we get the answer means the second one. This one again, we put the set based on the order P3 here, P2 here. Now this is the joint set. So we start with this step. 1 map to 2, 2. These two refer to these two. Not these two. Refer to this one. So 2 map to 3. So the first answer is 1, 3. That's right. 1, 3. Then second, 2 map to 1. This one, we refer to this one. 1 map to 2. So the final answer is 2 map to 2. So here 2, 2. 3. 3 map to 3. So this 3 map to this 3. 3 map to 1. So the answer will be 3, 1. Actually, this final answer equal to P5. If we look on the pattern, P3 join with P2 here. P3 plus 3 plus 2, it will be P5. If we follow the sequel, this sequel. Okay, that's the idea about join. Okay, now we look on the this exercise. This exercise given to you, if A 1, 2, 3, 4, 5, 6, it means there are 6 elements. Once we talk about permutation function of A, it means we must have 6 relation where given to this one given P1 and P2 given. It can be any value between 1 and 6, but this value must have a pair the pair is 1-to-1 radiation bijection. Okay, for example here, we have 1, 2, 3, 4, 5, 6, 1 map to 3, 2 map to 4, 3 map to 1, 4 map to 2, 5 map to 6, 6 map to 5. This is P1. P2 given to you, 1, 6, 2, 3, 3, 2, 4, 5, 5, 4, 6, 1. Now, refer to P1, do the inverse process. So P1, this is P1. Once we inverse P1 inverse, it will be 3, 4. We change the position. 1, 2, 6, 5. It will be 1, 2, 3, 4, 5, 6. Now we rearrange back to the ascending order. It will be 1, 2, 3, 4, 5, 6. So we look on the pair. So 3, 1. So 3, 1. 4, 2, 4, 2. 1, 3, 1, 3. 2, 4, 2, 4. 6, 5. So 5, 5, 6. So 6, 5. So this is the answer. Okay, 3, 1, 2, 2, 4, 4, check back. Okay, 4, 2, 2, 5, 6. Okay, yes, this is the answer for this question. So far, okay, class? For exercise A, 1A, any question? Everybody get the answer, how to get the answer? Everybody? Okay, good. Now we move to this question. Okay, faham, good. This question. So this question we put the based on the location. So P1. So follow P2 join with P1. So we put P2 first. So P2. So P2 1, 2, 3, 4, 5, 6. Okay. One also 1, 2, 3, 4, 5, 6. Here P2 6, 3, 2, 5, 4, 1. So P1 3, 4, 1, 2, 6, 5. Okay. What is the answer once P2 join with P1? So the answer will be, we start with this one. So it will be 1 map to 3. So we must find 3. 3 map to 2. So the answer will be 1, 2. So 2. 2 map to 4. 2 map to 4. 4 map to 5. So the answer will be 2, 5. 3 map to 1. 1 map to 6. So it will be 3, 6. Then 4 map to 2. 2 map to 3. So 4, 3. 5 map to 6. 6 map to 1. It will be 5, 1. So 6 map to 5. 5 map to 4. So the answer will be 6, 4. 6, 4. So this is the final answer. Okay, class. Actually easy if you follow the step. Okay, class, the others okay dah? Okay, Amar, thank you. Okay, good. Okay, Kai, good. Amira, okay, good. Now we focus on the third question in exercise 1. So actually it is same step, but we must convert first. We must convert this P1, we inverse first. P2, we inverse first. Then we rearrange. After we rearrange, we do the operation. Actually the same step. Should I show to you? See? Or you can do by yourself? Class? So you can do by yourself, huh? No, sir, show us. Okay, I will show to you. sorry. Okay, this one. So first we get P1 inverse. So once P1 inverse, it will be, oh, sorry. Okay, P1 inverse. So P1 inverse equal to 3, 4, 1, 2, 6, 5. Will be 1, 2, 3, 4, 5, 6. So it will be like inverse. Change back 1, 2, 3, 4, 5, 6. So 1 refer to 3, 2 refer to 4, 3 refer to 1, 4 refer to 2, 5 refer to 6, 6 refer to 5. Okay, this is P1 inverse. So P2 inverse, P2 inverse, it will be 6, 3, 2, 5, 4, 1. Maybe 1, 2, 3, 4, 5, 6. So finally, it will be 1, 2, 3, 4, 5, 6. So it will be 1 refer to 6, 2 refer to 3, 3 refer to 2, 4 refer to 5, 5 refer to 4, 6 refer to 1. So this is P1 inverse, this one is P2 inverse. So the question is P1 inverse joined with P2 inverse. So it will be P1. This is P1. So we write P1 first. 1, 2, 3, 4, 5, 6. P2 1, 2, 3, 4, 5, 6. So P1 3, 4, 1, 2, 6, 5. P2 6, 3, 2, 5, 4, 1. Okay, now we join. Okay, it will be 1, 2, 3, 4, 5, 6. So 1 map to 6, 6 map to 5. The answer will be 1, 5. 2 map to 3, 3 map to 1. It will be 2, 1. 3 map to 2, 2 map to 4, 3, 4. 4 map to 5, 5 map to 6, it will be 4, 6. 5 map to 4, 4 map to 2, 4, 5, 2. 6 map to 1, 1 map to 3, so 6, 3. So this is the answer. Okay. Okay, class. So far, so good. So your question maybe look like B and C, either in test or either in your assignment. Okay, good. Now we move to another idea. Okay, theorem 1. Theorem 1 said if we have A with this element A1, A2 until AN, so the set containing n we can put as a factorial equal to n times n minus n until and so on until 2 times 1 until 2 times 1 permutation of a. It means once we have b permutation b1 actually equal to b2, b2 actually equal to b3 permutation of b2 and so on. So this idea we call as a cyclic permutation of length r where we put as b1, b2, b3. What it means? It means once we have a permutation, it means we can put in cyclic permutation like this one. We have 1, 2, 3, 4, 5, 6, 4, 5, 6. If we have permutation, actually this idea look like 1 map to 2, 2 map to 3, 3 map to 4, 4 map to 5, 5 map to 6, 6 map to 1. this we call cyclic permutation. Okay? The cyclic permutation refer to this idea. Class, okay tak? Okay, because after this we talk about cyclic permutation. I mean, we talk about maybe there are two cyclic of permutation. Okay. Another idea, once we have put like this one, once we show this is cyclic, so we put like this one. 1 join with 2, join with join with 3, join with 4, join with 5, join with 6. So from here, once we show that this is a cyclic, we put in this idea. So how we represent in discrete? We represent through this idea. So once I write the relation 1 join with 2, join with 3, join with 4, join with 5, join with 6, it means all these values are joined. It means interconnect each other in this cyclic permutation. Sometimes given to you, this cyclic permutation can be like 1 join with 2, join with 3, and this join with 4, join with 5, join with 6. What it means? It means we have two cyclic. 1 join map to 2, 2 map to 3, 3 map to 1. And another cyclic is 4 map to 5, 5 map to 6, 6 map to 4. This is the idea of this representation. Okay, from this idea, we extend the concept of permutation like this two cyclic. So far, okay? Class? Amar? Okay, Amar? Okay, tak, Amar? Okay, good. Okay, now based on that idea, now given example 4, we have 1, 2, 3, 4, 5, and the cycle 1, 3, 5. And then how we represent 1, 3, 5 in this relation? So we look on what is the cycle 1, 3, 5. It means 1 map to 3, 3 map to 5, 5 map to 1. So we have 1 map to 3, 1 map to 3, then we refer to 3, 3 map to 5, 5 map to 1. So based on this representation, we represent in metric like this one. 1, 3, 5 have a cyclic. The other sustain. So 2 they have no change. It means 2 map to 2, 4 map to 4. Okay. So another idea, once we have 3 map to 4, 5 map to 2, map to 8 map to 2. This cycle 3, 5, 8, 2. So this cycle actually similar or equal to this cycle, and this cycle. Why? Because input rearranged in order. It may be 3, 5, 8, 2. It may be 5, 8, 2, 3. It may be 8, 2, 3, 5. It may be 2, 3, 5, 8. Kejap, kelas. Nasi goreng kampung. Sorry. Okay, so if we have this cycle, we can represent either through representation, this one, or this one. Okay. Okay, class? Okay, Class, are you okay? Cik Nazifah okay tak? Class? We still okay, good. I need a response from everybody. Okay, bagus. Now we look to another idea from cycle permutation, where we talk about product but there are two things in product. Either the product is need a cycle or can be not as a cycle or not be as a cycle. Here, example 5. Given to you 1, 2, 3, 4, 5, 6, it means there are relation between each of this value. Given to you the cycle 4, 1, 3, 5, 5, 6, 2, 5, 6, 3. So find either which one is disjoint, which one is not the cycle. Okay. So 4, 1, 3, 5, 5, 6, 3. So once given to you this permutation and this permutation, it means the first permutation only involve this 4 value, 4, 1, 3, 5. It means 4 map to 1, 1 map to 3, 3 map to 5. Another permutation only consider 5 map to 6, 6 map to 3. So based on this situation, we can produce the first permutation 4, 1, 3, 5. So 4 map to 1. Then 1 refer to this one, 1 map to 3. Then refer to 3, 3 map to 5. Then 5 map to 4. Here, look like. So this only relation have relation based on different value. The others is same value, 2 map to 2, 6 map to 6. First permutation. Second permutation refer to 5, 6, 3. So 5 map to 6, 6 map to 3, 3 map to 5. So we refer to 5. 5 map to 6. Then 6, 6 map to 3, 3, 3 refer back to 5. The others sustain. Once we get this to permutation, then we do a joint operation. This is a joint operation. So as actual previously, 1 map to 1 refer to this one. 1 map to 3. So the answer will be 1, 3. So here 1, 3. Second, 2 map to 2. These two refer to this 2 map to 2. No changes. So 2, 2. 3 map to 5. 5 map to 4. So 3, 4, 3, 4. 4 map to 4. This 4 map to 1. It will be 4, 1. 5 map to 6. 6 map to 6. So 5, 6, 5, 6. 6 map to 3. 3 map to 5. So 6, 5. This is the answer. Okay. The second actually is we try to change the position. 4, 1, 3 will be the second permutation. 5, 3, 1 will be a first permutation. We change. We will see is that the answer is equal. Okay, now B. We change, we get 5, 6, 3. 5, 6, 3. Okay. Second, 4, 1, 1, 3, 3, 5. The others are set. Now we do the operation. 1 map to 3. 3 map to 5. So the answer 1, 5. 2 map to 2. 2 map to 2. So the answer 2, 2. 3 map to 5. 3 map to 5. 5 map to 6. 3, 6. 4 map to 1. 1 map to 1. So 4, 1. 4, 1. 5 map to 4. 4 map to 4. So 5, 4. 6 map to 6. 6 map to 3. 6, 3. So 6. This is us. Now we compare. This answer and this answer actually is different. So we can say based on the observation, if we have this kind of operation, we change the position of the position, the answer actually is different here and here. Okay, that's the idea. That's the idea of this cycle to permutation. Okay, so far so good. Anis Najah, okay tak? Are you okay, Anis?
Okey, sir. Dengar
Bagus.
faham.
Tengah faham.
Ha.
Okey, bagus. Ada orang lapar nasi goreng. Saya baru order nasi goreng. Okay. Okay, now we move to the next idea. This one, cycle. Okay. In this example 6, we talk about two cycle, but the cycle sometimes can be as a disjoint. Can be as a joint. For example, here we have a set 1, 2, 3, 4, 5, 6. Once we have two cycles here, 1, 2, 5, one cycle, 3, 5, 3, 4, 6, this cycle. If this cycle, we have these two cycles, this cycle is disjoint. Why we say disjoint? Because the value involved in this cycle and this cycle, this is the do not overlap. Means here 1, 2, 5, 3, 4, 6. It means this value do not involve in this value. It means disjoint. Once we check like this one, for example, 1, 2, 1, 2, 5. 1 map to 2, 2 map to 5, 5 map to 1. So we have another cycle, 3 map to 4, 4 map to 6. So it means this cycle and this cycle disjoint. So that's why here we call disjoint. This cycle and this cycle is not disjoint because involved here we share the same. How we prove it? We show like this one. 1, 2, 5. Suddenly we have 2, 2, 4, 6. 2 map to 4, 4 map to 6, 6 map to 2. So this is not disjoint. This is joint. Because of 2 shared by these two cycles. Okay, that's about disjoint and joint. Okay, theorem 2. Theorem 2 said with theorem 2 talk about disjoint but product of disjoint. What is the product of disjoint? Product of disjoint product means in maths means we times or multiply. So for example, given to you permutation 1, 2, 3, 4, 5, 6, 7, 8 with this permutation. So give set A 1, 2, 3, 4, 5, 6 is a product set of disjoint cycle. Okay, this is a disjoint cycle. Why? You see here 1 map to 3, 3 map to 6, 6 map to 1. So this is only the cycle involved. Another 2 map to 4, 4 map to 5, 5 map to 2. So another one cycle. So we have another one cycle, 7 map to 8, 8 map to 7. So we can draw or we can visualize this this relation, this permutation is a product of the disjoint. How? We show 1 map to 3, 3 map to 6, 6 map to 1. So first cycle. The second cycle is 2 map to 4, 4 map to 5, 5 map to 2. Okay, another cycle is 7 and 8. 7 map to 8, 8 map to 7. So we have 3 cycles here, but this cycle is disjoint. So the total of this cycle we call as product of disjoint cycle S, because 3 cycle. So we can say if given to you this permutation, so you can write like this one of the set A 1, 2, 3, 4, 5, 6, 7, 8 is as a product of disjoint cycle because each of cycle do not link. That's the idea of theorem 2. So see, we start with the idea like this one, then given to it, first cycle, second cycle, and first cycle, second cycle, and third cycle. So how we represent all the cycle? How we represent in permutation function? So we represent the cycle through this. We put as 7, 8, 1 relation. Join of product set of 2, 4, 5, 1, 3, 6. So we write like this representation. So P is 7, 8, 1 relation, another 1 relation, another 1 relation, 2, 4, 5, another 1 relation, 1, 3, 6. This is the answer. Okay. So how to write like this one? You must write like this one. P, first relation, second relation, and third relation. Okay. Another idea is even and odd permutation. So how we know even and odd permutation? Based on the relation. Okay. For example, given to you once you get like this one, from here, finally you get a product of this joint cycle of P. So you count how many involved here. 1, 2, 3, 4. It means even. So we call even permutation. That's it. Another idea. Given to you the permutation like previously 7, 8, 2, 4, 5, 1, 3, 6. So produced as a product of transposition. So you need to split this because this is more than 2. Here more than 2. We need to split. How you split? We need to 2 map to 4, 2 map to 5. Here 1 map to 3, 1 map to 6. So we can simplify like this one. 1, 3, 6, 1 map to 6, 1 map to 3. 2, 4, 5, 2 map to 5, 2 map for 4. So once you simplify this one, you list back. So this one, 1, 8, 2, 5, 2, 4, 1, 6, 1, 3. So you count. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5. It means odd permutation. This one, 1, 2, 3, 4, even permutation. That's it. That's the idea of even permutation and odd permutation. Okay. Exercise 2. Okay, given to you this A, B, C, D, E, F, G. Find the product of A and B. Okay. For this one, we have this representation. Now we simplify. It will be A, F, A, G. A, G. Okay, for this one, A, B, C, D. It will be B, C, B, D, B, E. So it will be B, C, B, D, B, D, B, E. So is that even or joint? So it will be 1, 2, 3, 4, 5. It means odd permutation. Odd permutation. So how about this one? This one will be, this one sustained, then this one will be BC and BF. A, B, A, C. So it will be F, G. So 1, 2, 3, 4, 5. So this one is odd permutation. Okay. Class. Oh, sorry. Class, okay. This is a last slide. So far, okay. Class. Okay, good. So that's it for today about permutation function. Okay, that's it for today. So thank you very much.
Okay, thank you, sir. Bye-bye.
Okay, bye-bye. So that's it for today. Bye-bye. Okay, attendant. I don't want to uh give attendant through manual. You stand by, scan yourself.